Hi, in this video, we're gonna talk about Boyle's Law. The history of Boyle's Law, based on what I have researched, in the 17th century, Richard Townley and Henry Power discovered the link between pressure and volume. Robert Boyle confirmed their discovery through experiments and published the result. Boyle's Law is based on studied with air, which he regarded as a fluid of particles at rest between minuscule invisible springs. Air was still considered one of the four elements at that time, but Boyle was convinced otherwise. Boyle was most likely interested in comprehending air as a vital component of life. Boyle utilized a closed J-shaped tube and caused the air on the other side to contract under the pressure of mercury after pouring mercury from one side. He discovered that under control conditions, a gas's pressure is inversely related to its volume occupied after performing the experiment multiple times with varied concentration of mercury. So what is the definition of Boyle's law? The law itself can be stated as follows: for a fixed mass of an ideal gas kept at a fixed temperature, pressure and volume are inversely proportional. Or Boyle's law is a gas law stating that the pressure and volume of a gas have a inversely relationship. If volume increases, then the pressure decreases, and vice versa, when the temperature is held constant.
What is Boyle's law? The law was named after chemist and physicist Robert Boyle, who published the original law in 1662. Boyle showed that the volume of air trapped by a liquid in the closed short limb of J-shaped tube decreased in exact proportion to the pressure produced in the long part of the tube. This empirical relation, formulated by the physicist Robert Boyle in 1662, states that the pressure of a given quantity of a gas varies inversely with its volume at constant temperature. In equation form PV equals to K, a constant. The relationship was also discovered by the French physicist Edme Mariotte in 1676. Boyle's law, also called Mariotte's law, a relation concerning the compression and expansion of a gas at constant temperature.
Boyle's law. Boyle's law is named after the Irish natural philosopher Robert Boyle, who was the first to publish it in 1662. Earlier, in 1660, he had sent his finding in a letter to Charles, Lord Viscount of Dungarvan, eldest son to Earl of Cork. The relationship between pressure and volume was brought to the attention of Boyle by two friends, amateur scientists, Richard Townley and Henry Power, who discovered it. Boyle confirmed their discovery through experiment and published the result. According to Robert Gunther and other authorities, Boyle's assistant Robert Hooke built the experiment apparatus. Boyle's law is based on experiment with air, which he considered to a fluid or particle of rest, with small invisible spring between them. At that time, air was still as one of the four elements, but Boyle didn't agree. Probably Boyle's law interest was to understand air as an essential element of life. He published The Growth of Plants Without Air. The French physicist Edme Mariotte, 1620 to 1684, discovered the same law independently of Boyle in 1676. So this law may be referred to as Mariotte's or Boyle-Mariotte law.
Hi, I'm Denise, and my part in this presentation is about how to solve a problem using the Boyle's law. Before we start, I'm going to show you a basic idea behind Boyle's law. Pressure and volume are inversely related. If you decrease the volume, the pressure will increase. Likewise, if you increase the volume, the pressure will decrease. Now the equation that is associated with Boyle's law is P1 times V1 is equal to P2 times V2. So this is the equation you're going to use when solving volume and pressure problems. So this is the shape of graph that is associated with Boyle's law. So let's say pressure is on the y-axis and volume is on the x-axis. If you think that the shape of the graph is going to be a straight line, no, rather it is going to be a curved line. Now let's try solving some problems. Number 1. A 2.5-liter container has a gas pressure of 4.6 atm. If the volume is decreased to 1.6 liter, what will be the new pressure inside the container? Now let's make a list of the given units. V1 is 2.5 liter and the pressure that corresponds to that volume is 4.6 atm. Now the volume is decreased to 1.6 liter, so that's the new volume and we're looking for the new pressure, which is P2. Of course, the equation that we're going to use in this problem is P1 V1 is equal to P2 V2. P1, which is 4.6 atm, times to P2, which is 2.5 liter, is equals to P2, which is we're going to look for, times 1.6 liters. If we multiply 4.6 atm and 2.5 liters, we're going to get 11.5. And then you're just going to combine 1.6 liters and P2. And then we divide 11.5 over 1.6 to get our new pressure. And our new pressure is equal to 7.19 atm. Now, we make sure that the answer makes sense. We decrease the volume from 2.5 to 1.6. So therefore, the pressure should increase from 4.6 to 7.19. So that's it. You know how to solve the problem using the Boyle's law.
According to Robert Boyle, the volume of a confined gas is inversely proportional to its pressure when the temperature is constant. So this is the materials needed. Be careful when using sharp objects. Cut the bottom of the bottle by using knife, scissors, or cutter. Be very careful in handling these sharp objects. You can also just bore a hole at the lower end of the bottle and you will see the same result. Cut off the narrow opening of one of your balloons, leaving you with a piece similar to a shower cap. Stretch this balloon around the bottom of your plastic bottle, making it like a drum membrane. Take the other balloon and fold the opening of this balloon around the rim of the bottle, hanging it upside down inside the bottle. Slightly pull the balloon up the bottom of the bottle. Observe what happens to the balloon at the top. Now let me explain how that happened. So as we pull the balloon membrane at the bottom of the bottle, there will be an increasing volume of gas inside. This in turn will decrease the pressure inside the bottle, making it unequal with the pressure outside the bottle. Since the pressure outside the bottle is higher than the inside, air molecules are pushed inside the balloon at the top of the bottle. Because of this, the balloon gets inflated, making the volume of air inside the bottle decrease back to normal. This is very similar to how our lungs and diaphragm work. And so again, as the volume of the confined gas increases, its pressure decreases, and vice versa. And this is Boyle's law.